Hello, this is John from caveofprogramming.com. In this tutorial in C++ for complete beginners, we're going to look at classes in C++. I've actually been taking a look at how much more C++ would need to learn in this course before we can make, for example, a simple graphics program, and the answer is still quite a bit. So I'm going to try to work through everything that we need before we can make something a little bit more interesting, hopefully, than a console mode program. So I'm going to start from scratch here. I'm going to create a new project. I'll go to File, New C++ Project. Let's select Hello World C++ Project here, and I'll call this Classes, and we'll click Finish. So classes are they're a way of combining or kind of packaging together data and subroutines, and you can think of them as a way of defining your own variable types, if you like. And these kind of definitions are not going to make much sense just yet, because what a class really is kind of contained in how you use it. So we need to see really how to use it and what you can do with it. So let's go ahead and create a simple class. I'm going to start by right-clicking the project. Well, let's actually just build it first and check that it works, because I always like to make sure that we're definitely starting with a working project. So it says Hello World, that's good. And I'm going to right-click the project and go to New, Other, and I'm going to select header file here. Yeah, let's start with the header file. In fact, the stuff I'm about to show you, there's a quick way of doing it, which involves selecting class here. But I'm going to do this kind of more by hand than is strictly necessary in order to show you what's involved. And I'd recommend that to start with, you do it this way too. So we'll select header file, click Next. And I'm going to create a class to represent a cat, like the animal a cat. It's going to be an extremely simplified model of a cat, needless to say, but it is going to be a model of a cat. So I need to choose a file name here for my header file, and it's important to follow some kind of convention with your source files. And I'm going to follow the Java type convention here, which is that if I create a class called cat, I'm going to give the header file the name cat with an uppercase first letter. So I'm going to say cat.h. Because header files have the .h extension. So I'm going to start it with an uppercase first letter, and I'm going to give it the same name as the class that I intend to define. Let's click Finish there. So this looks, well, we've seen all this before. This is just stuff that's aimed at preventing multiple inclusion of the same code if you have multiple includes directives in different files in your project. Let's also create a matching.cpp file. So far we've been working with just one .cpp file in our projects. We've got one here called classes.cpp that contains our main function. But let's create another one now, because we can have multiple ones in our C++ project. I'm going to right click the project or the source folder, it doesn't matter, and go to New, Other. In fact, that option was already available in the menu, but that's only because I previously selected this. Let's go to New Source File under the C++ section here. Click Next, and I'm going to call this cat again with an uppercase C.cpp. So let's click Finish. Now, after the comment here, we can expand the comment. But this is just a comment. We could delete it. It doesn't matter. I am going to include. Let's just get rid of it actually, because I don't really want it. I'm going to include the header file. So I'm going to say hash include double quotes and with uppercase C cat.h. So we've got two files here. We've got a header file with the usual if not def stuff in it that we saw last time. We've got a CPP file that includes the header file. In the .cpp source file, I'm going to start by defining a function here. Let's call it meow. So I'm going to say, or speak, let's say speak, void speak, empty round brackets there. It accepts no parameters. and I'm just going to put the curly brackets in, and I'm going to put cout and meow, which is the noise a cat makes in English. Anyway, so I'm using cout here, but I can't use cout at the moment because I haven't included iostream. So let's do that. Let's put that right at the top. Since it's a standard header, we'll put the standard headers right at the top of the file before any new headers that we've invented. And I'm going to say here, include angle brackets this time because it's in a standard location, this header file, iostream. And underneath the headers, I'm going to type using namespace standard. We'll take a look at namespaces in due course, but we haven't seen them yet. So for the moment, just know that you need to type this. Namespaces is just a way of dividing up different bits of code, basically. So now we've got that in, this speak should work. But now, supposing I want to call that in my main function here, supposing I want to call speak, let's get rid of the cout here. I can't just call speak like this because the compiler hasn't seen speak at this point. Let's save it all. Go to project, build project. I expect to get an error because it doesn't know what speak is. We need to somehow allow the compiler to access this speak function that's defined in this separate .cpp file. How can we do that? Well, you might guess we can go to cat.h here and we can put void speak in there. In fact, we could, now that I think of it, it's certainly possible that we could just type void speak here. We could do that. Let's save that and see if it builds. Let's build project here. And we'll run that. And it says meow. So that works. But you're gonna want to use functions that are defined by other people. And you're not always gonna know what the prototype should look like. So for that reason, we put the prototypes of related functions in particular header files, like iostream. Let's cut that from here, put it in cat.h. So now we've got this kind of self-contained thing going on. We've got a cat.cpp containing some functions, just one in this case, but it could be lots of them. And we've got a cat.h containing the prototype for that function. Now, all we have to do in this main function here is above there, let's put below our include iostream, let's just put include cat.h. Remember, it's got an uppercase first letter. And let's build that, project build, and run it. And it says meow. So we just put the prototype of this function here in the header file, and then we can include that wherever we want to use it. And we can call that function here in the main function. We also included cat.h here in cat.cpp, and that's not actually necessary at the moment. Let's just delete that. Let's save everything, go to project build. So it's going to work fine without it, but we need that for what we're going to do in just a minute. Now, C++ is a language that's built on a language called C. I imagine, I don't know, there are probably languages called A and B, but C is one that really took off. And C++ had extra extensions to make it what we call object-oriented, or object-orientated. Yeah, I think usually you say object-orientated, actually. So anyway, it was common in C, and you also still see it in C++, to define functions in files like this. So you get all your kind of related functions. For example, all your functions connected to user input, or all your functions connected to graphics or whatever, and you put them all in one file, and then you'd have a header file where you put all the prototypes, and then you'd include that wherever you wanted to use it, wherever you wanted to use those functions. That was a common way of organizing code in C, and it's still often used in C++. Let's just define another function here just to underline the point. Let's say void jump, And let's say here, these are very minimal dummy functions, of course. Let's say jumping to top of bookcase, endler, semicolon. And we can just put in the include file here, we can say void jump. Let's run that. Well, that's not going to be any different from before, but we can go to classes.cpp and we can call it, if we want, jump, save it and run it, and it should say here jumping to top of bookcase. So this was a typical way to organize C programs, and it's still used in C++. But the kind of disadvantage here is that if you think about what a cat is, and here we're trying to write functions to represent a cat, it's not just stuff that it can do. A cat doesn't just jump and make meowing sounds and so on. It also has a state. Like the cat has a position, it has a mood, it has, you know, a level of hungriness and so on. It has a state to it, and we want to represent the state by variables, and that's why classes were invented, to bundle data that represents the state of a thing together with the subroutines that represent what it can do. So let's see in this tutorial just how we can bundle these functions together into a class, into what we call a cat class, and how we can create particular instances of cats that can then do stuff. So the changes we have to make now, they're fairly minimal. What we do is, let's go to cat.h firstly, and above these functions I'm going to type class cat. I'll give it a capital C. You don't have to, but it's important to have some convention for how you name classes and to stick to it. So I'm going to follow a Java type convention and start my classes with a capital letter here. And then let's open and close curly brackets here. And I'm going to move these function prototypes into this class here. So this is pretty simple, and we've seen this pattern a lot before. It's just a keyword and a name, and then open and close curly brackets. Well, we've seen similar patterns for sure anyway. And above these two functions, which notice must be within these curly brackets following class cat here, above that I'm going to type public and a colon, not a semicolon, a colon. And when I hit return there, or when I finish typing it, the auto formatter automatically moved it backwards like that. And that is correct. I can run the formatter again just to be sure, but yeah, it doesn't do anything. So we've just grouped these functions within this class, within the brackets of this class, and we've put a public keyword above them. And we'll get onto what that means in more detail later on in this course. But basically, it makes those functions accessible outside of the files that are purely associated with this class, so that we can use these functions, for example, in our main function. Now we're going to go to cat.cpp. And just before the function name here of speak, let's start with that one. I'm going to prefix it with cat. That's the class name. It's this here. And colon, colon. So 2 colons. And I'm going to do the same with jump. So this is saying that these functions belong to this cat class. And what this is it's kind of like a blueprint for a cat. At the moment it's very simple. It hasn't got any data, it hasn't got any state. We've just used it to bundle our two functions together. But it's kind of like a blueprint, we call it a class. And the specific instances, the actual cats that are made from this blueprint, we call them objects. So let's see how we can create a cat object from this class. So I'll go back to my classes.cpp, and we've already included cat.h here. Now we've got errors because we can't just call speak and jump like we did before. But I'm going to type, and this looks like defining a variable, which it is. I'm going to type cat, that's the name of my class, which again is here. It's not the name of the file that it's in, I just gave the file the same name as the class. But it's important to realize it's not the file name, it's the class name that I'm typing now. So cat, and then I'll give it a variable name. And my convention that I'm using is variable names start with lowercase first letters. So let's just call this cat. I could call it, just cat is good really, and then a semicolon. So that's like saying int value or something like that. Some people think it's confusing if you have a class name and a variable name that are exactly the same except that the class name has an uppercase first letter. C++ is case sensitive, so if you feel like you could give this some other name, like you could call it cat1 if you like, let's call it cat1, but I quite like, often where possible, giving my variables the same name as classes, and I can tell them apart because I'm giving the classes uppercase first letters, but it's a matter of opinion, certainly. Now to call the functions, which are now bundled into this cat class, we can say cat1 dot, and the autocomplete is helping us here. Let's select speak, and let's also say cat1 dot jump. So this dot notation, let's try to use control space, autocomplete, that actually works. So just holding down control and pressing space, invoke the autocomplete there. I'll type semicolon, and this will now run as before. So if I run this, it runs those two functions, but we've bundled them into this cat, and we have to access them via this cat variable. So this is the class, this is like a template for a cat, and this is a particular cat. We call it an object that's, we say it's instantiated from the class. So it's like having a blueprint, making a cat from a blueprint. We call that instantiation, and we call the finished actual particular cat, we call it an object in the lingo here. So we're going to be seeing a lot more of this in future tutorials, but this is already very long, so I'll leave it there for now. It's important to practice this yourself. Try to define your own class. It doesn't matter what it does, try to define it. And whenever you get stuck, you can refer back to this code, study this code, and make sure that you've got everything that you need to have, just as I have here, to make it work. But try to get your program to build and run. Try to have 2 or 3 methods in your class that you can call in your main program. And once you've succeeded at doing that, especially if you manage to do it all from memory, which would take quite a bit of practice, I think, at this stage, then you've definitely mastered everything you need to know so far. So until next time, happy coding.